Hello guys and welcome back to my channel Interview with Bunny, and we are back with another video on system designing playlist, and the topic or the application that we will be designing today is called the stock trading platform or a stockbroker such as Zerodha, Upstox or Groww. So this type of platform are nothing but stockbroker which actually help us in buying and selling of the stocks from the exchange. So just to give you a clear understanding, there is a very huge difference between a stockbroker and a stock exchange. So during your technical interview, just listen to your interviewer that which application he wants you to design, because if he wants you to design an exchange, this is not the video for you. But if he wants you to design a stockbroker like Zerodha, then this is the actual video that you are looking for. Because in a stockbroker or a trading platform, we take the exchange as a complete black box where there will be few open APIs from our exchange where the actual trading and the allocations of the stocks happens on the trading platform, and all the trading and the monitoring of the stocks where you can see in display does happen on the stockbroker. So with this assumption that you have a complete idea of what actually happens on the stockbroker, or you are already familiar with some of the application like Zerodha, Groww or anything, let's proceed further with the first step of our system designing video, and that is the functional requirement for this application, and that is the stock trading platform. So let's start with the first step of our designing. So the functional requirement for any trading platform is quite simple and straightforward. So the first one is user should have the ability to register into our platform and do all the KYC validation so that he get authenticated to do any trading in our platform. Number two, user will have the ability to view all the current price of the stock in the near real time as well as all the previous data, means it can be a year old data, a week old data or whatever the time range he provides. Number three, users should have the ability to place an order to buy or sell a particular stock. It can be an order based on the market value, or it can be on a particular limit on which he want to buy or sell a particular stock. So this will be our third requirement. Now the fourth requirement is user should have the ability to create his own watch list. And the last but not the least, user should have the dashboard where he can see all the transactions and the P&L and all the metadata related to a particular transaction, means what is his profit or the loss, or what is the status of his past order. So these are more or less all the 5 requirements that we are targeting for this system designing. So let me first list down all this functional requirement over here. So these are more or less all the functional requirements that we have gathered from our interviewer. Now since we are done with our functional requirement, let's move to our next step, and that is the gathering of the non-functional requirement, where we deal about the characteristics of the system, means how the resilient your system is or how efficient or optimized your system should be. All those core characteristics comes under the non-functional requirement. So let's see what are the non-functional requirements that we have to fulfill for designing this application. So the first non-functional requirement that we collect from our interviewer is we try to know the scale of the system, because knowing the scale of the system is crucial before designing a particular system, because based on your scale, your architecture will vary accordingly. So let's see what can be the scale of the system. So whenever you will ask your interviewer that what is the scale that we are targeting for this system, he will be telling that here we are targeting a millions of users and there are millions of transaction in a particular day, and the total number of stocks that we are dealing is around 8 to 10k. So this is the scale of the system that we will be targeting while designing our system. So let me list down all these points over here. So here you can see the scale of this application is quite huge, because here we have to handle a high frequency transaction and the total number of users that we are targeting is also quite huge. But obviously there are only a limited amount of stocks in our exchange, so it will be around 8 to 10k as the upper limit, because in current system in India we are having 5 to 6,000 stocks that are listed under BSE or NSE. And that is why here we are targeting a 8 to 10 total number of stocks in our exchange. Now let's go to the next important core concept of our non-functional requirement, and that is the CAP theorem. And as you know, the CAP theorem tells that whenever you are creating a microservice or a distributed architecture, you either have to compromise with the high availability or with the high consistency of our application. Means a particular module of our application cannot have both the property of high availability and the high consistency together. And if you see in our application, since it is dealing with stocks, money and all these things, so our application should be highly consistent than that of the availability. So here we will be giving the priority to the consistency rather than availability, because in our application it is fine that our server is down for a couple of minutes or so, but it is not fine that you make a transaction where your payment has been deducted from your bank but the stock is not booked on your name. So those type of consistency is highly required in this type of system. So here the consistency of the system highly matters while you are designing a stockbroker application or whenever you are dealing with money, because at any particular time if there is a problem with the consistency in our system, there can be a billions of dollars of loss in our system. So here we will be giving the priority to the consistency rather than the availability. So let me list down all that point over here. Now comes the next point for the non-functional requirement, and that is the latency of the system. And here if you understand, the latency of this system should be as nominal or as minimum as possible, because obviously we need to see the near real-time update of the stocks from the exchange. So whenever there is a minute change on the price of the stock, we have to get that changed value in the near real time. And also whenever we want to place an order into our exchange, that also should happen in near real time. So obviously the latency of this application should be as minimal as possible. And as I have already told you, in our system designing, whenever you are giving a non-functional requirement, try to quantify all this value. Means here for placing a particular order, the latency of that transaction should be less than 100 milliseconds, and whenever you are seeing the real-time update of the stocks, then it should be the less than 50 milliseconds. Means it should be a near real time. So let me list that point here. So here if you see, the latency is quite aggressive, because in a distributed system it is very difficult to achieve this type of latency in the real world. But here there is an added advantage to this architecture, that is whenever we are discussing about a stockbroker or a trading platform, it is not a global platform that we are designing, because mostly in each and every country they have their own stockbroker platform. Means here we are not supporting that Zerodha will maintain the stocks of the US market, or we can place an order on the US markets. So whatever the things that we are designing will reside within our country. So if you are designing any stockbroker for the US, so all the data center and the clouds will be residing on the geographical location of the US. Similarly, if you are creating for the Indian market, then we have to deploy all our server and the cloud within the geographical location of the India. Means all the caching and all of the layers that we need for a particular system designing should reside within our region. So obviously with that advantage in mind, that all our servers are present on a particular geographical location, this is now quite an achievable thing to do. So here you can see these are more or less all the functional and the non-functional requirements that we need to collect from our interviewer before starting with our design. So since here we are clear with all the functional and the non-functional requirements for our system, now let's proceed to the second step of our designing, and that is the identification of the core entity. And identification of the core entity is quite simple if you just go through this functional requirement. So here if you easily understand that the core entities that are involved within this application is number 1 the user, number 2 the stocks, number 3 the orders, number 4 the trade that is happening with the exchange, and number 5 the portfolio, where you can see all the profit and the loss for a particular transaction. So these are more or less all the 5 core entities that we can figure it out over here. Also along with that there is one more thing, and that is the watch list, that will be another core entity over here. So let me list down all those core entities so that it will be easy for you to understand. Now, since we have already identified the core entity, let's proceed to our next step, and that is a crucial and one of the main important thing for this stockbroker application, and that is the API designing. And believe me, there are a lot of endpoints that you have to point out over here for designing this application. So without wasting much time, let's see what are the public API REST endpoint that we have to expose for our user to fulfill all the functional requirements that we have gathered. So let's move to the third step of our designing, and that is the API designing for our application. And as I always tell you, API designing is actually quite simple if you have done the functional requirement correctly, because in most of the cases, API designing have one-to-many relationship with each and every functional requirement that you have collected. So let's see what are the major REST endpoints that we have to expose for the user. So the first one is we have to give the provision for the user for the authentication and login. So let me first list down all the endpoints that are needed for a particular user authentication and onboarding service. After that, I will let you know what is the functionality of each and every endpoint over here, and I will make it clear so that it will be easy for you to understand. So the first few endpoints that we need for the user onboarding service is number one, the sign up, the login, and the KYC verification. So obviously, once the user lands to our application, what we have to do, he have to first submit the data into our backend system so that we can onboard or register a particular user. And since here we are submitting some data, so obviously this will be a post call. And once he is done with the registration, he have to go with the KYC process. Since in our Indian market, KYC validation is very much important for any of the stockbroker application. So here we have to give the provision for the KYC verification. And the last but not the least is the login by which he will be able to log into our application. So these are more or less all the endpoints that we need to onboard in our application. Now let's see what are the endpoints that are needed for the user to see all the prices of the stocks in the near real time. So let's point out all the endpoints that we need to see the prices of all the stocks from the market or from our exchange. So these are more or less all the endpoints that we need to get the data for our market. So the first one is the stocks endpoint, which is nothing but a GET API, which lists down all the list of the stocks from our exchange. So since here we are targeting about 8 to 10 thousands of the stocks from our exchange, so obviously all these things should come in the form of the pagination. And now the next one is like, once the user gets all the list of the stocks, obviously he want to see what is the current price of that particular stocks. And once he clicks on the name of that stock, all the bar chart and all the graph should come up on the right side. And for that, to get the information of a particular symbol of a stock, we are having our next endpoint, that is this one, which will give us the real-time update of a particular stock. Means what is the present or the current value of the stocks. And here if you see, there is one more API, that is to see the history of the stock data. Means for example, you want to see all the history or the past value of the stocks for the last 15 to 20 days. For that you have our second endpoint, which show the history of the price. I hope this is clear. Now, since we are done with the two things, that is the user onboarding and number two, the details of the stock, now let's go to the next step, and that is the trading. But before trading, what you need? You need money in your account. And for that, you need our next endpoint, that is for the payment service, where you can deposit the actual money into our wallet so that we can do a trading. So let's see what are the endpoints that we need for loading money into our trading wallet. So these are all the endpoints that we need to deposit our money into our wallet, to withdraw the money from the wallet, and to see all the history of the transaction that we did in our application. So these are quite a straightforward and easy endpoint. I hope you can easily understand. Now the next thing that we need, since here we are done with all the three major endpoints, that is the user onboarding, the market value, and the fund in our wallet. Now the next thing is like, we have to place order to our exchange. Means whichever stocks you want to buy, you have to place the order accordingly. So the next list of endpoint that you need are nothing but our trading endpoint. So let's see what are the endpoints that we need to successfully place an order into our exchange. So these are all the 4 API endpoints that we need to place a particular order. So here you can see here we have the first endpoint to place the order. Number 2, we have the second endpoint to see all the orders that have made by a user. Number 3, the details of a particular order. And the last but not the least, for example, you want to cancel a particular order, that you can easily do it with this endpoint. So these are all the list of API endpoints that you need to place a order. And here if you see, for placing a particular order, here we are using a post method, and obviously as you know, when you are sending a post endpoint, obviously you have to send the post body. So all the metadata of the stock means, for example, what is the name of the stock, what is the quantity, what is the price at which you want to buy a particular stock, and all those metadata should be going in the form of the post body for this particular URL. I hope this is clear that how we are making a transaction into our application. Now, since we are done with placing our order in our application, now we will be interested to see what is the profit and loss for a particular order. And for that, we need our next endpoint that will give you the overview of the portfolio of a user. So let's see what are the endpoints that we need. So to get the portfolio of a user, these are all the get endpoints that we need. That is for seeing the portfolio, the holding, the position, the performance. And here if you see, I am not explicitly mentioning the user ID for which we want to retrieve the information. But how we will be doing? We will be sending the user data, means the user ID of a particular user, in the header of the request. That will make our endpoint quite secure and safe. I hope this is clear. And the last but not the least, few of the endpoints that we need for designing this application is for creating a watch list for the user. So let me list down those endpoints also over here. So here you can see these are all the endpoints that we need for creating a watch list. So here if you look carefully, these are almost all the endpoints that we need for designing this application. But believe me, to be very honest, designing this many amount of endpoints during your interview is actually not possible. So discuss with your interviewer that which actual core concept he want you to emphasize or explain, and design that aspect accordingly. Because in most of the cases, you have to focus on this market data, the trading, and this portfolio thing. Because apart from that, this fund management and this watch list is not that much important for designing. The two most important thing is this market data, and number 2 is the trading. And since during your interview, since you have very limited amount of time, so just focus on these two aspects first, and after that, if you have enough time, then discuss all these 3 other endpoints that you need for all the other functionality that you have to design. I hope this is clear that how you will tackle this question during your technical interview. So here if you look carefully, we are almost done with our 3 step of our designing, and that is the gathering of the functional and the non-functional requirement. Number 2, identification of the core entity, and the third point, and that is the API designing. Now since we have already got the overall concept that what the things that we have to design, let's proceed with our next step of our designing, and that is the high level designing of our application, where we will see that what are the major components that you need actually, or what are the major services that we need to fulfill all the functional requirements that we have gathered over here. So let's move to our 4th step of our designing, and that is the high level design. And the high level designing of this application is actually quite simple, because in the high level designing, we are not going into the detail of each and every service. Rather, we are just showing an abstract view of what are the services or the components that we need to fulfill all the functional requirements that we are gathering, and how we are talking with the exchange, which is nothing but the NSE or the BSE. So let's see what are the components or the services that we need for designing or fulfilling all the requirements that we have gathered. So the first thing that we will be designing over here is the user or the clients who is actually using our application. So the first thing or the first module that we require in our designing are the user component. And this user or the clients for our application can be anything. It can be a web application, it can be an iOS application, or it can be an Android application. So all those things comes under the client part of our application. And since here we are targeting a millions of users with a high frequency of trades, so obviously we have to go with the microservice architecture rather than a monolithic architecture. And whenever we are designing a microservice architecture, so obviously at that time we need a load balancer or a API gateway by which we can distribute the load in our backend service in an eventual manner. So for that, what we need here, we need our first component of our application, and that is the load balancer or the API gateway. And the roles and the responsibility of the load balancer and the API gateway is number one, the authentication and authorization. Number two, the crucial thing, and that is the rate limiting. Number four is the routing of the API based on the URL endpoint, and the algorithm that we will be using here to distribute the traffic uniformly in our load balancer will be the round robin algorithm. So let me list down all these points over here. Now, since we are done with the basic setup of our designing, that is, we got the user and the API gateway. Now let's see what are the major components that we need to fulfill all the requirements. So the first thing that we need is the onboarding of the user. And obviously, since we are onboarding a user into our application, we need our first service, and that is the onboarding or the user service. So here we will be having our first service called as the user service. And since we are onboarding the user, so obviously we have to keep the data of the user in our backend. And for that, we need our backend service or the backend database to persist all the information. For that, here we will be having our first database or the first table of our application, and that is the user DB. I hope this flow is clear. So what is happening? All the requests are first coming into our load balancer. And based on the API endpoint, the load balancer will divert our traffic to the user service for the onboarding process. And once the user is done with the sign up or the registration, all the data will get saved into our user DB. But remember, this is not a straightforward process over here, because here we have to do one more level of the authentication. That is, here we need to do a KYC validation for the user. And to implement that, there are 2 to 3 ways by which you can do so. Number one is you can yourself do a KYC verification by doing an integration with our authenticator service like UDI, which is a government website where you can do all the KYC verification. But I believe this is not a public endpoint which everyone can use. You have to get the license to hit all their endpoints to do the KYC verification. Or otherwise, what you can do, you can easily use a third-party library who does all the KYC verification for you guys. So in our Indian market, there are a lot of services or startups that are present who does all this KYC verification for you. So you can use one of their application for all this KYC verification. So here also what we will do, for doing a KYC verification, we will use an external application to do so. So here we will be having one more application, and that is actually a third-party application to do all the KYC verification. I hope this is clear. So now since we are done with the user onboarding process, now let's move to the next step, and that is how we will see the real-time value of the stocks. And for that, what we need a service to fetch all the information of a particular stocks or the list of stocks from the exchange like NSE or the BSE. So what we'll do, here we will be having our next service called as the price tracker service, whose main responsibility is to get the value of the stocks from the exchange. So here we will be having our next service called our price tracker service. And from where it will get all the values of the stocks, all the value from the exchange that we have in India, that is the NSE or the BSE. So here we will be having our next module, which is obviously a black box for us. That is the exchange that we are having over here, which is NSE and the BSE for our Indian market. I hope this is clear. Means whatever the prices that we are getting from the NSE and the BSE, this price tracker service is actually fetching this information from this server and it is showcasing in the front end. So this is actually the flow that we need over here. Now, how this will be done and what type of connection, all these things that we will be discussing in our next phase of our designing, that is in the deep dive analysis or the low level designing, where we will see in detail that how all these things will be done in the real world in the near real time with the negligible latency. But right now, since we are doing the high level designing, let's see what are the other components that we need. So here, since we have already got all the live traffic or the live prices of the stock, now what we have to do? We can do two things. Number one, we can watch list all the stocks for our future use, or we can place an order. So first what we'll do, here we will create our watchlist service. So here we are having our next service that is called our watchlist service, which will simply store all the stocks information or the stocks that you want to save as your favorites in a particular DB. And for that, we need another table over here, which is nothing but our watch DB. So let me create another DB that is called as a watch DB. I hope this is clear. So now we are done with few of the important steps. That is, number one, the onboarding of the user. Number two, the live tracking of the stock price. Number three, creation of the watch list. Now, since we are done with the premises of our application, now the next step is we have to place the order to our exchange. And for that, to handle that scenario, we need an order service whose main responsibility would be to take the order from the customer and place it in the exchange. Because all the allocation of the stocks we are not doing in our end. It is done by the exchange, as I have told you at the very beginning. So all the allocation of the stocks, all things related to the price and everything, that is actually done by the exchange module that we have over here. That is with the help of NSE and BSE in India. So here what we need, here we need one more service, and that is the order service. And since here user is making the order of stocks to the exchange, obviously we have to keep a track of those, that what are the stocks or what is the quantity or price of which the stocks has been ordered. So for that, to keep the track, over here we will be using a DB. So here we need one more database or a table called as a order table, which will keep track of all the orders that we are performing in our system. And before placing the order into the exchange, there is a crucial step that we have to do. That is, we have to validate the order. And how the validation happens? So validation can happen in many ways. So for example, it can be a user validation, means whether the user is KYC validated, whether he have enough money in his wallet, and all those validation should be taken care in our backend. And once that order is validated successfully, then only we should push it in our exchange. Because whatever the request that you are doing in the exchange, that is actually very costly, because to get the license of the exchange, or based on the total number of requests you are hitting on the exchange, the brokers have to pay accordingly. And that is why we have to see this fact that the total number of hit requests or total number of requests we are sending to the exchange should be as nominal as possible. Also, there is another important thing. Since this exchange is an external services, so obviously the time taken for a request to travel from our server to a third-party service will be much more. So here, to optimize all those things, what we have to do, first thing, we have to validate all the orders that are getting placed in our application. So here we will be having one more service called as a validator service. And here, once the order has been validated, then what we have to do? We have to submit that order in the exchange. Clear? So this is the flow by which our order will take place in our application. So it's the first thing what the user is doing. User is hitting our load balancer, and thereafter the router is routing the traffic to our order service, and thereafter it goes to the validator, and thus the order gets successfully delivered to the exchange. Clear? Now, since we are done with ordering of a particular stock, now the next thing is like, we will assume on the high level that once we place the order, it will get validated and it will get a successful notification from the exchange. Means your order has been successfully placed. And thus an acknowledgement will come from the exchange, and thus we have to update it in the order DB. Now, once the order has been placed successfully, obviously the next thing the user would like to see is like, what is the profit or loss of the particular order? And for that, to see the analytics or the insight of an order, we need one more service called as the portfolio service. So here we will be having one more service called as the portfolio, and this portfolio will talk to the order DB to check that what are the orders that you have placed. So this will be our next service called as the portfolio service. I hope this is quite simple and straightforward approach. And one more thing that we have to include over here also, that is we have to include a payment service to upload the wallet of the broker by which we can place our order successfully. So here we will be having one more service, that is a payment service. And as you know from all my earlier video, a payment service should have a payment database and also a payment service called an external service, that is a third-party payment gateway. So there will be one more service over here which will talk to the actual banks for the transaction, that is nothing but a payment gateway. I hope this is clear. So here if you look carefully, with this simplified design, we have almost covered all the functional requirements that we have gathered. That is number 1, the user onboarding, number 2, the live tracking of the stocks, number 3, the buying and the selling of the stock with the help of our order service. After that, we have our portfolio service to see all the analytics and the performance of the stock. Thereafter, we have the watch list and the payment gateway to load money in our wallet. So here if you look carefully, more or less we have covered everything that is required to design our trading platform such as Zerodha or Groww. But the things are not at all as easy as it looks like, because here if you look carefully, here we have easily taken an assumption that the order service that we have created over here is simply placing the order in the exchange, and we are assuming it once the order has been placed, we will get a success or a fail notification from the exchange. But in the real life, this actually doesn't happen, because it might can happen that you are placing an order of 20 stocks of Reliance, and at a particular instance only you get 5 stock of the Reliance, and after a 5 to 10 minutes there will be another 15 stocks that will get allocated to your name. So it might happen that there is a partial fulfillment of the stocks that you are booking. So it is not possible in the real world that whenever you are placing an order into the exchange, you will get the notification of the acceptance of the stocks in near real time. Along with that, here if you see, we have created the price tracker service, and here if you see, we are calling the exchange to get the real-time update of the stock, but we have not discussed in detail that what type of connection it should be or how we should be updating it to the user. So all those things we will be discussing in the next phase of our designing, and we will see in detail how each and every service will get designed and how they will interact with each other, because here if you know, there will be a lot of interaction across the services to check the real-time update of the prices. So let's see in our next phase of our designing, that is in the next step, that is the deep dive analysis or the low level designing of our system, where we will see in detail that how each and every component that we have designed over here will interact with each other. So let's move to the last step and the final step of our designing, and that is the deep dive or the low level designing of this application. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So the first thing that I will do, I will just copy this entire design from our high level into our low level section so that I can extend this design even further. So here the first component that we will be designing is the user service, which is very easy and a straightforward service. That is, here the main responsibility of the user service is onboarding the user, which is actually quite simple. And here if you look carefully, we are using a third-party library or a third-party services for the KYC validation. So there is not a huge amount of logic that we have to create in our user service. So our user service is quite straightforward and simple. Only thing that we have to design is what are the attributes that we need in the user service, or what are the metadata that we need to save for a particular user. So let's see how the schema structure will look like. So obviously, since this user table is a straightforward metadata of the user, so what we will do, we will use a simple RDBMS, that is a Postgres or a MySQL solution. So let's see what will be the schema structure that we will be saving in our user table. So these are more or less all the attributes that we need in our user database. So here we have the user ID, the email ID, the phone number, name, and all the metadata that we need for a particular user. But along with that, here if you see, there is one more flag that we have to save for each and every user, that is KYC verified. So what happens is like, since here we are using a third-party services over here, so what we will do, all the information of the Aadhaar card, the PAN card and signature and all those sensitive metadata, we will actually not keep it in our database. Rather, what we will do, we will give all the responsibility of saving all this sensitive data or information to our third-party library, which is actually doing all this KYC validation. And once this external service is done with the verification, then what it will do, it will simply return a flag like true or false, and based on that we will simply update this variable, that is the user is successfully KYC verified or not. But in case you want to save the PAN card or the Aadhaar card details of the user in our database, so remember that is optional totally, and the data that you have to save in our database should be in the encrypted form, because those are the sensitive data and that should not be saved in a textual format. So here this will be the schema structure of the user DB. I hope this is quite simple and straightforward. Now the next thing that we will be doing is another important service and another simple service, and that is the payment database. So this is also very simple and straightforward solution. That is, here we are having the payment service. I will just move it upward, and this payment service is also quite straightforward. That is, here we are having the payment service and all the transactions of the bank will go to the first to our payment gateway, and from that payment gateway we will get the acknowledgement of the success and the failure message from the gateway. And once it is success or failure, what we will do, we will update that information or the transaction details in our payment DB. And since it is a payment related information and it should be highly consistent, so what we will do, we will simply use a MySQL database, or you can simply go with a Postgres solution similar like this. And let's see what will be the schema structure of this database. So these are more or less all the nominal data that you need to save for a particular payment. That is the transaction ID, the user ID, the amount he want to save in the wallet, the timestamp, currency, and all those things. So these are some of the very simple services that we have already designed in our past 11 videos. So it is not something that is new. So I'm just giving you the idea that what are the attributes that you need to save in our database. Now let's go to some of the main component of our application and one of the crucial service of our application, and that is the price tracker service, which is actually the heart of our application, where we can see all the live tracking price of the stocks and we will update to the user in almost in near real time. So let's see how these things should actually get designed. So here, if you look carefully, what we are doing in our price tracking service, we are actually getting the price of each and every stocks from the exchange. And there are a few ways we can actually perform this logic. The first one is like, we can periodically fetch the data from our exchange. Means, for example, at a particular second, means at the 0th second, we will check that what is the current price of all the 5 to 10,000 stocks that are currently present in the exchange. So we can send a request to our exchange, and obviously the exchange will return stock in the form of the pagination. So that can be one of the approach. And in the next second, that is in the T+1 second, we have to again send one more request into our exchange to fetch the updated price of the stock. So in each and every second, since here we are creating an application where the stock price changes, we have to hit this exchange service in each and every second, and we have to update the front end accordingly. So, but here you can easily understand this is very much a trivial solution to this problem, and with the help of this solution, you can actually not create this application, because you can easily understand that at each and every minute you have to hit this exchange database to fetch the information of the stocks. And you can easily understand that since our market opens for 6 hour window or so how many amounts of the request that we have to send it into our exchange. And obviously remember, since each and every request that you are sending in the exchange will create a price, since it is chargeable, so it is not an ideal way to solve this problem. So let's see what can be the better or ideal way to get the price of the stock in near real time. So the next approach by which we can solve this problem is with the help of the SSE connection. Means whenever there is a change in the price, the server, means our exchange, will send the value or the updated value of the stock in our system. So what will happen is like, this will be actually a SSE connection, and the responsibility of the SSE connection is like, it is more or less like a long polling thing. But what happens is like, the exchange is actually doing the job. The exchange is feeding the data or sending the data whenever there is an update in the stock price. So this can be one of the solution to this problem. And if you see in Google or YouTube, most of the video, I can say 90% of the videos that is there solving this problem statement are using this SSE connection. But believe me, I have done a thorough research on this thing. But in real life, what actually happens is like, the exchange does not support, or it is not recommended to use a SSE connection to connect to a particular exchange. Rather, what exchange tells that you have to keep a open connection or a duplex connection, means you have to open a bidirectional WebSocket connection to get the real-time update of the stock price. So here, if you look carefully, this is quite a controversial thing, that whether you have to go with a WebSocket connection or you have to go with a SSE connection. Because if you see the fundamental difference between the SSE and the WebSocket, that is, in WebSocket it is a bidirectional connection, means both the sender as well as the receiver can send the data simultaneously. But in case of the SSE connection, only the server is allowed to send the data, not the client. But here, if you see in our application, we do not have to actually send any data to our server. It is only the server or the exchange who have to send updated value of the stock in our backend. So in the very initial state, it might looks like that the SSE connection will be the ideal solution or the ideal type of connection that we should create over here, because the exchange will keep on sending the data into our service. But in the real life, it is not the SSE connection, rather it is a WebSocket connection. Now, why we are using a WebSocket connection? I will explain you in detail that why a WebSocket connection is needed for this approach, and how the WebSocket connection will create advantage in creating this type of solution. So let's see, with the assumption that WebSocket connection is the ideal choice for this type of connection, let's proceed further. But do not worry if you are confused why I am going with the WebSocket connection. I will give the explanation once we are done with the entire solution of this price tracking service. So let's proceed further. So the first thing that we have to create over here if you see, or here if you look carefully, what we are doing, all our internal services we have created over here is actually talking to the exchange service. But it is not advisable, or it is not possible to directly talk to the exchange with some internal services. So what we need here, we need one more service actually as a gateway to the exchange. For example, the way here we have used our API gateway or the load balancer as a reverse proxy, means this client doesn't know that which is the services that it is talking to, means it is simply throwing our HTTP request or the API request into our API gateway, and this API gateway is routing the traffic accordingly. Similarly, over here also, this exchange should not get the information that from which services this request is getting generated. Rather, it should be a single standalone service or a standalone gateway from which all the requests should come to this exchange service. So what we need here, we need one more service or a one more gateway which will more or less act as a proxy for this entire backend. So here we will be having one more service that is nothing but a exchange gateway, means all the requests that will be going to the exchange should go via this gateway service. So this will be our next service, that is our exchange gateway. I hope this structure is clear. So this exchange service is only responsible to directly interact with this exchange service. Now, as I was telling you just a minute before, all the connections to get the data of the stock should be in the form of the WebSocket. Means here, all the connections that we are doing with the exchange or with the exchange gateway should be in the form of the WebSocket connection. So all these things are nothing but a bidirectional connection. And as you know, both the WebSocket connection as well as SSE connection are capable to send the traffic in near real time once there is an update in the price within this exchange service. So what we are assuming that whenever there is a change in the price of the stocks, all those metadata are coming into our exchange gateway from this exchange service. Clear? Now, obviously, since this is a WebSocket connection or a SSE connection, let's assume as of now, obviously, there will be millions of information of the stock that will come in the near real time. Because for each and every second, the price of all the 5 to 10,000 stock will change accordingly. So, all those information will come as a back pressure, means all the data will get feed into our exchange service in near real time. And obviously, to handle that amount of streams of data in near real time, our price tracking service is not enough to handle that type of load. So what we need here to handle that amount of streaming data, we need a streaming platform such as a Kafka broker. So here what we need a Kafka broker to handle that amount of back pressure of the stocks update over here. So here all the data that the exchange is sending will first go into our Kafka broker. I think this is clear because obviously those huge amount of data that will get ingested through the exchange service will not be able to handle by this price tracker service in near real time. And that is why here to keep it as a buffer, we are using a Kafka service over here. Clear? Now, a Kafka service will have multiple topics to save the information. And the first topic is like the stock price. So here the first topic will be the stock price. Clear? So whatever the data that the stock exchange is sending in near real time, we are simply storing it in a Kafka broker as a buffer. Now, what we have to do? We have to feed this data into our front end. As well as there is one more functionality that we have to provide. That is here, if you look carefully in the functional requirement, here you can see we have to give the functionality that users should be able to see the real-time value of the stock as well as the historical data of the stock. So to get the historical data, obviously it is not advisable to call our exchange one more time to get all the previous data. Rather, what we will do, here we will create another database where we will save all the previous price of the stock. So whatever the price of the stock of the Reliance was there on the last week or the last month, obviously to get that information, it is not ideal or we should not hit the exchange service over here. Because I have already told you, each and every time you are hitting an exchange service, you have to pay for it. So you have to see that the total number of hit that you are doing in the exchange service should be as nominal as possible, because just to give you information, just to get the license of using this API actually cost in crores in Indian stock market. So for example, Zerodha is using the exchange for 1 month. It have to pay in crores to the exchange to handle all the APIs that are there in the exchange service. So you can easily understand that all this call that you are doing in the exchange are actually very expensive. And obviously here you have to optimize as much as possible. So here to save that time as well as the expense, what we have to do, all the past information of the stock, means what was the price of the stock a minute ago, all those things we have to save it in our local database, so that whenever a user is coming into our service, for example, a user is opening our application at 2 o'clock and the Indian market have already started from 9:15. So all the past data from 9:15 till 2 o'clock, all those past data we can easily get it from our local DB, and whatever the real-time change of the stock starting from the T0, that will come via the WebSocket connection that we have created from the exchange. Means all the real-time data we will get it from the exchange in with the help of the WebSocket connection, and whatever the past data that is from T-1, all those past data we are getting it from our database. So what we have to do, once the price value are already there in our Kafka broker, we have to save it in our database. And the best possible solution or the best database to save all the data of the stock based on the time frame is nothing but a time series database such as InfluxDB. So here what we will need, here we need a time series database to save all the metadata of the stock price on each and every second. So here what we will do, here we will create one more database called as the InfluxDB, which is nothing but a time series database. And how we will insert all this data into our InfluxDB from this Kafka service? For that we need a consumer service over here. So here we will create one more service called as the price ingester service. So here we are having our next service called as the price ingester service. And the responsibility of this price ingester service is quite simple. That is, whatever the data that is coming into this topic, that is the stock price, what it will do, it will simply consume that data from the Kafka and it will push it in the InfluxDB, so that all the real-time data get persisted in the InfluxDB in the near real time. Clear? So here with this approach, whatever the data we are getting from the exchange are getting persisted in our DB. But still now we have not find out a way that how the price will get to the front end to the user. So here for that what we need another service over here. That is nothing but a PubSub connection. Let me draw it over here, and after that I will tell you how the data flow will actually work. So here what we will do, here we will take the help of our Redis PubSub. And this Redis PubSub will have all the LTP of the stock, means the latest transaction price of the stock. So whenever this ingester service is getting the data from the Kafka, it will do two things. Number one, it will insert the data in the InfluxDB, as well as it will insert the data in our Redis PubSub. And why we are inserting in the Redis PubSub? So that whatever the subscriber who is subscribed to this Redis PubSub will get the data as near real time as possible. So what actually happens is like this price tracker service will have to subscribe to this Redis PubSub over here. So this will be nothing but our price tracker service. And this tracker service is actually subscribed to this Redis PubSub, so that whenever there is a change in the stock price, the data are coming into this Redis PubSub, and as soon as the data comes over here, if the user is subscribed to that stock, it will simply come into this price tracker service as a pushback. So here the arrow will be something different, that is the data is coming as a pushback from the Redis PubSub to our price tracking service. If you are still confused and not clear, do not worry. Once we are done with this entire flow, it will be 100% clear with you that how everything is working over here. Since here we are going in from the back to front, so it might be very difficult for you to understand. But once we are done with this complete setup, it will be very straightforward and simple solution over here. So what we are doing over here, all the clients who are actually talking to our backend services are also using a WebSocket connection to connect to our backend. Here also we are not using a SSE connection to send the data from the backend to the front end. Why? I will tell you very soon. So here, whatever the open connection you are seeing over here to get the real-time price of the stock are all the WebSocket connection. So what we will do here, we will do a small modification. That is, since I've already told you that if your application is WebSocket heavy, you have to go with a dedicated WebSocket gateway. And that is why what we will do, I will just divide this gateway into two sections. Number one is the API gateway and number two is the WebSocket gateway. Means all the REST endpoint that you are hitting to access this service will go via the API gateway, and all the open WebSocket connection that is required to fetch the price of the stock will go via the WebSocket gateway. So what I will do, I will just simply divide this thing into two components. So here I have divided the entire gateway into two components. Number one is the API gateway and number two is the WebSocket gateway. Because you already know that in our last few videos, I was telling you that if your application is WebSocket heavy, it is advisable to use a dedicated WebSocket gateway rather than passing the request via the API gateway. Though all our modern API gateways support the WebSocket connection, but it is better to have a dedicated WebSocket gateway for easy session management and session stickiness. So here we are having the two components over here, and here the connection that we are having to talk to our price tracking service is nothing but a bidirectional WebSocket connection, and this service is our WebSocket server. Clear? So what is actually happening here is like, once the user want to see the price of a particular stock, our WebSocket connection is getting established in our backend. And for example, the user want to see the price of the ICICI Bank. So what it will do, here in the WebSocket connection, it will say that I want to subscribe to the price or the stock of the ICICI Bank. So a connection will get opened over here. That is, I want to check the price of the ICICI Bank, and here this price tracker which is subscribed to this Redis PubSub will also tell that I want to check the price of the ICICI Bank only. So all the real-time data that is coming into our Redis PubSub mechanism via this ingester service will get feed into this WebSocket server, and it will get pushed to this client in near real time. Clear? But there is a small problem. That is, here this WebSocket connection only tell you the current real-time price of a stock. But to create the graph of a particular stock, you not only need the current price but also the previous information of the stock, means the previous day information or the previous stock of the price. And to get the previous information or the historical data of the price, what we are doing here, this price tracker service will talk to this InfluxDB. Clear? So what is happening? For example, you are coming into our application at 12 o'clock. So all the data from 9:15 till 12 will get fetched from this InfluxDB, and starting from the 12 o'clock, whatever the data you are getting in the near real time, all those things will be served by this Redis PubSub mechanism. Clear? Now, for example, the user want to see only the price of the ICICI. Now, on the next second, he want to check the price of the Reliance or few other stocks that he want to see or he want to purchase. So at that time, what will happen? This WebSocket connection that we have opened with the user, that here, since it is a bidirectional connection, we will send a notification. This existing user want to check one more price of the stock, means not only the price of the ICICI Bank but also the price of the Reliance stock. So here you can see, here from the user side we are also sending data via this API connection, and that is why we need a WebSocket connection rather than a SSC connection. Because remember, changing the data on the SSC connection means, for example, you want to right now check the price of the Reliance, thereafter you want to check the price of another stock. For subscribing to different stock at a particular moment, you have to open the SSC connection each and every every moment whenever you are changing the subscription. So for example, at the time 0, you want to check the Reliance, so you have to open a SSC connection to get the price of the Reliance. Now on the next second, if you want to check another price, what will happen? You again have to send one more SSC connection into our backend, but right now with two attributes. One is the ICICI as well as with the Reliance. So here you can see whenever you are opening multiple stocks in your front end, for each and every new entry, you have to open one more new connection, and to replace that, to make this thing efficient, what we are doing here, we are using a WebSocket connection, so that till the point the user is active in our application, a bidirectional duplex connection is established between the client and the server, and whatever stock he want to see in near real time, he only have to subscribe that stock, and the data will get fed from our front end to the back end, and corresponding data will come from in near real time from the back end. So that is why here we need a bidirectional connection rather than a SSC connection. Clear? I hope this is clear that why we are going with a WebSocket connection rather than a SSC connection. Similarly, over here also I will explain you the same thing, that why we need a WebSocket rather than a SSC connection. But as of now, I hope you got the idea that whenever a user want to opt for a particular stock, he have to only send that much information from the front end into our back end, that I want to subscribe for this many amount of stock, and with the help of the open WebSocket connection, it will easily get subscribed to this WebSocket server, and this WebSocket server will get all the previous record from this InfluxDB and all the current information from this Redis PubSub. I hope this is clear. Now with this idea in mind, just think of this thing also. That is, for example, you have opened a WebSocket connection with the exchange. Now, for example, your application have just started right now. So only a single user is there in your application who want to just see the stock of the Reliance. So what you have to do with the SSC connection, you have to subscribe to the exchange with only a one stock ticker, that is Reliance. Now once the second user comes to your application and he want to see a different stock, again you have to stop the existing connection, and after that you have to again send a notification to the exchange that right now I want to see the price of the two stock. So in this way, if there is 50,000 stock in the market, so you have to keep on killing the previous SSC connection, and you have to send a new SSC connection to get all the information of the market. But with the help of the WebSocket connection, it is much simple. That is, here just have to send that I have open WebSocket connection with the exchange. Here right now I just want to add few more subscription or few more stocks in our connection, and just send it accordingly. And thus you can see all this connection will be persistent connection, and you do not have to fluctuate the connection, and you have to break the connection whenever the user want to see the latest price of a particular stock. I hope it is clear that why we are going with a WebSocket connection in the entire design rather than a SSC connection, and how many WebSocket connection which will be open with the stock exchange. So based on some of the information available on the Google, what I found out that on a particular WebSocket connection with the exchange, you can transfer 300 to 500 price of the stocks. Means on a particular WebSocket connection, you can subscribe to 500 stocks at a time. So if you have 5,000 stocks in the NSE or BSE, you have to open 10 WebSocket connection in the backend. So this is how the WebSocket estimation will look like. So I will write down all these things in this flow so that it will be very easy for you to understand in the future. So here if you see, I have updated all the data flows over here. That is that the user is subscribed to the stock using the WebSocket connection. All the past data are coming from the InfluxDB. All the real-time data are coming from this Redis PubSub mechanism. And all this data are getting fed using this price ingester service, who is getting the live data from the exchange with the help of the Kafka broker that we have. So if you just go through this flow, it will be clear that how the things are working over here. But there is a small thing that you have to keep in mind while designing this system or while explaining it to your interviewer. That is, if you remember that, for example, few thousands of users are only trading on few of the 2 to 3 thousands of the stock. But in the real market, there are total 5,000 to 6,000 stocks in the market. So to have all the information of the stock, it is necessary that whenever your server is up and running from 9:15, your backend server, means your exchange gateway, should enable all the WebSocket connection, subscribe to all the stocks that are available in our BSE or the NSE exchange, because it can happen that there are some of the stock that no one is interested, but in the future if someone wants to view that stock, we have to show them all the past data of the stock, means what was the price of the stock yesterday or day before yesterday. And to do that, we need that data in our InfluxDB. And how we can make it happen? That can only happen when we subscribe to that stock in each and every day when the stock market is opening. So basically on each and every day, we have to open all the WebSocket connection, subscribe to all the stocks that are available, so that whether the user is consuming it or not, all the data are present in our Kafka and it is present in our Influx database. Clear? So this was one of the important things to notify. Now since we are done with the price tracking mechanism, let's now see how the other services will work. So here if you look carefully, here we are having a watchlist service. Now what is a watchlist service? It is just like a saved list of all the stocks. And how we can do it? You can easily do it with the help of the API call. Means whatever the stock name is there, we can save it in a Postgres on a MySQL database, and we can map with all the user with all of his favorite stocks. So let's see how the watch database will look like. So here how the things will happen. So here we are having two tables within our WatchDB. Number one is the mapping between the user ID and the watch list. So basically a particular user can have multiple watch lists in our system. So maybe he is interested with all the finance watch list. So he can create his own finance watch list and can enlist all the stock within that. So in this way, there is a one-to-n mapping with the user and the watch list in our applications. So here for a particular user, there can be multiple watch lists. So here there will be one more ID called as a watch ID, that is nothing but a auto-generated number. So for a particular user, there can be multiple watch list ID present in our application, and these two will become our candidate key. And for a particular watch list, there can be multiple symbols or multiple stock within a watch list. So it will be a list of symbols that is mapped to a watch list. Clear? So that is quite a simple approach of designing a WatchDB. And obviously, since it is a relational data, so we will be saving it in a Postgres solution. Now, what actually happens is like once you open the watch list, whatever the stock you have enlisted within a particular watch list, you get that stock price in the near real time. And to do so, what we have to do, this watch list service should also talk with this price tracking table. For example, me as a user have created a custom watch list where I have saved 5 stocks. Now, whenever I open a particular watch list, I should be able to get all the values of 5 stock in near real time together. And for that, what we need here, this watch list service should talk to this price tracking service, so that whatever the past data, we can see it from the InfluxDB, and whatever the real-time update should come from our Redis PubSub. Clear? So here you can see that these two databases can only be read by a single service, and that is the price tracking service. So whenever we need a service that needs a near real-time data, that service should talk to this price tracking service that we have over here. Now, since we are done with two of the things, now let's see another important thing, that is how this order service will work. That is again another important thing in our design. So it is quite obvious that in our non-functional requirement, we have taken one point, that is we should be able to handle high frequency trade from millions of users. And whenever we are taking this type of non-functional requirement, you have to keep in mind that it is not possible for a single server to handle that amount of load from the user. So to handle that amount of heat from the user, what we have to do to make our system resilient and consistent, what we need here, we need a buffer to save all the events of ordering that is coming from the user. So what we will do here, I will create a broker or an event streaming platform like a Kafka broker. So all the events like buy, sell or whatever first comes from the user to this Kafka broker. And within this Kafka broker, what we are doing, we have to store it in a particular topic, and maybe we will call it as a raw order. So this is our first topic of our Kafka service, that is the raw order. Means whatever the user is doing to buy or sell a stock will first come to this Kafka event. Now what we have to do, once we get all the orders from our user, what we were doing in the high level designing, if you remember, we were running a validator service to see whether the order is a valid order or not. So what we will do here, before placing the order, we have to run a validator service on top of this Kafka. So whenever a particular order is getting posted within this Kafka in this raw order topic, it will get consumed by this validator service. And what is the responsibility of the validator service? So this validator service will do all these things. That is, it will first check that once the order has been placed in our application, whether the user is KYC authenticated, whether the account is active or not, whether the stock that you are purchasing matches the fund and the margin validation or not, whether the order is placed when the market is open or not, and all those validations should be done by this validator service. And obviously to do this validator service will have to talk to this user DB as well as it have to talk with this payment database. So I just mentioning all these points over here. So these are the responsibility of the validator service. And now, once the validator service validates a particular order, what it have to do? It have to again resubmit that, and it have to classify it whether the order is a valid order or it is a rejected order. So here what we need? Here we need two more topics in this Kafka broker. One is called the verified order and another is called as a rejected order. So here, based on the validator service, all the order that is coming from the user will get classified into two sections. One is the verified order and another is the rejected order. Clear? Now, if the order is a verified order, means it is a good order and the user has the sufficient amount of balance and meet all the criteria of the stock market, then what we will do, here this order placing service or this order service will consume this from the Kafka broker, and then it have to forward that order into our payment gateway so that our payment gateway redirects that order to our exchange, that is the NSE or the BSE. Clear? Now, once the order has been sent to the exchange, we have to do two more things. Number one, we have to write that order status in this order database. Means here the order service have to write the order in this order database that this user have placed this order at a particular price. So all the metadata of the order should be present within this order DB. And since obviously this is a transaction related information, so we will be using a Postgres solution here also, and let's see how the schema structure will look like. So this is how the schema structure of the order DB will look like. So let's see what are the attributes that is involved over here. So here we have a order ID, the user ID who is placing the order, the stock ID for which he is placing the order type, the price, quantity, trade ID, and the status. Now let's see what is an order type and the trade ID. So here in our system, order type can be many things. For example, in the normal Indian stock market, whenever you are placing an order, there you can purchase an order based on the market value, or you can set a limit to your order. Means your stock will get purchased at a particular value at which you want to buy or sell. So based on that, means whether it is a market order or it is a limit order, you have to update this order type accordingly. Clear? And also here you can see there is a trade ID. So this trade ID, when you are placing this order, this will be first initialized with the null. Means the order have been placed to the exchange, but it is still not confirmed. So the status will be pending and the trade ID should be null. Now, once the order has been placed successfully to the exchange and it is confirmed by the exchange that all the stock allocation have been done successfully to a particular user, then obviously the exchange will send a confirmation to our stockbroker. And once we receive that confirmation, we have to update the status as well as the corresponding trade ID, that your stock got allocated to the name, and this is actually the trade ID or the response value that we got from the exchange as a confirmation. So this is how the order DB will look like. Now, another important thing this order service have to do is like it have to notify the user that the order has been placed successfully to the exchange. And for that, we need one more service, that is a notification service. So here we will be having a one more service that is called as the notification service. I hope this flow is clear till now. Now if you see, as I was discussing, there can be two type of order. One is the market order and another is a limit order. So the market order is the type of order which get executed then and then. Means whatever the price of the stock available at that point, it will get purchased and the exchange will send acknowledgement then and then. But in case it is a limit order, it might can happen that your stock will get executed or your order will get executed after 15 to 20 minutes. So there should be a job or something which can act as a callback or which can act as a webhook by which this executor service can transfer the data after 10 to 15 minutes. And to implement that functionality, what we will do, we will take the help of this Kafka broker that we have initialized before. So what will happen with the help of this WebSocket connection that we have already maintained with our exchange, the exchange will send all the acknowledgement of the stock in near real time into this Kafka broker. So along with this topic, there will be one more topic that will be there, that is the order status. Means whatever the order that got placed successfully, all those status will be coming into this topic. And as soon as that order confirmation comes over here in the Kafka, there should be a job to reconcile that data. And how we will do? Here we need one more service to reconcile the acknowledgement that we are getting from the exchange. And for that we need one more service over here called as the order tracker service. So what is the responsibility of this order tracker service? It will read the data from this Kafka broker that whenever there is a success order or a failed order status comes over here, it will simply read it from here and it will do two things. Number one, it will notify the user that the order has been placed successfully, means from the pending it got changed to success, as well as it have to update this order table, means the status of the transaction will now go from the pending to successful. Also it will update the trade ID over here. Now there is one more small thing that it have to do. Here not only it have to update this order DB, rather there will be one more database that it have to do, that is it have to update a trade DB. So let me list down that database and after that I will let you know that what is a real life use case of that database. So this is our trade DB. So whenever a particular order is successful or failed, it will basically go into this trade DB. Now there can be a question that why we are saving the same information in both the trade DB as well as in the order DB. The main reason is like, for example, whenever you are placing an order in our application, it might can happen that your order gets rejected by the validator service. And here if you see, this order service is actually reading all the orders that we have within this Kafka broker, whether it is a verified order or it is a rejected order. And all these records are actually present in the order DB. But whatever the orders that has been accepted by the exchange will only be present within the trade database, means whether it is accepted or failed, that amount of information should be present within this trade database, so that later on the day when the market closes, we can reconcile this trade database with the database of the exchange, that both the tables are in sync, so that in the future all the reconciliation job of the payments and all these things can happen easily. Clear? So how this trade database will look like? It will have more or less the same schema structure of the order. There is no change in the schema structure between the trade database or between the order database. Now, with the help of this trade database, we will perform one more thing. That is, here if you look carefully, we are having a portfolio service. And obviously, portfolio service is interested with only all the profit and loss of the stock that got booked successfully by the exchange. So to get that information, this portfolio service will not talk with this order database, rather it will talk to this trade database, so that we can only get the information of the stock where that the order has been placed successfully in the exchange. Clear? So that is why we need two databases separately, one for the trading and one for the order. So what I will do, I just will clean up a bit. So here this is how it will look like. So the portfolio service will read the transaction details from this trade database, and this portfolio service will generate all the P&L statement accordingly. But if you know, to generate the P&L statement, that what is the profit or loss of a particular stock, we have to see what are the stock a particular user have purchased, as well as we have to see that what is the current price of the stock, because based on that, based on the difference between that, we can only generate the P&L, means whether it is a profit or loss. And to get the real-time data of the stock, what we have to do, again, this portfolio service will have to talk to this price tracker service to get the real-time price of the stock. So based on the user, it will first see that what are the stock a particular user have bought, and based on that, it will create the P&L for a particular user. Clear? So I will write all these things over here so that it will be very easy for you to understand. And thus here you can see I have updated everything, that is this portfolio service is reading the data from the trade DB and it is calculating the P&L accordingly. And here this order tracker service is doing two things, that is it is updating the status of the order in the trade database, as well as it is updating the order in this order database. And also it is sending the notification to all the user that your order has been placed successfully and it got accepted or rejected by the exchange. I hope this is clear. And here if you look carefully, this order service is consuming all the rejected as the verified orders, and it is persisting in the DB, and it is only sending the order that are verified to our exchange. So here if you look carefully, we have almost covered each and everything that we have taken into consideration in the functional and the non-functional requirement. Only thing that is pending, that is how we are actually doing or managing the payment calculation in the backend. So if you see that here we are having our payment database, but actual transaction of the payment or actual calculation of the money is done by the exchange. So there should be a reconciliation job that should settle the money between the exchange and the broker that we have over here. So that can be one of the follow-up questions that your interviewer might ask, but that is too much information to consume. But here if you remember, while I was doing the API designing, I have intentionally done one mistake. That is, here if you look carefully, while I was designing the API endpoint for retrieving the market data, here I have given that this endpoint will be a GET endpoint. But in the real life, this is not a GET endpoint, rather it will be a WebSocket connection. And I hope you are right now clear that why we need a WebSocket connection, not a SSE connection, to design this entire functionality. So I hope you have thoroughly understood this video and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you in our next video where we will be solving another problem on system designing. So see you on our next video. Thank you.